right, so right triangle trig, of course, only applies when you have a right triangle. When we get the law of sines and cosines tomorrow, you can use that on any triangle. It doesn't have to be a right triangle, but what we're looking at today has to be with a right triangle. So you have to have a right triangle for the stuff that we'll be looking at today. So if I have an angle, which I'm going to label this angle right here, theta, then your trig ratios are going to be really important. Hopefully this is all a review in your board while I'm telling you this. But across from that angle, we call that our opposite side. The angle, the side across from the right angle, that is our hypotenuse. And the side next to the angle, but not the hypotenuse, is our adjacent side. So hopefully those are all words that you remember. We've got our 3 trig ratios that we have learned so far. That is sine of theta, which is opposite over hypotenuse. We've got cosine of theta, which would be adjacent over hypotenuse. And we've got tangent of theta, which would be opposite over adjacent. So these you should have seen before. They should be familiar. There's lots of little things to help you remember them. SOHCAHTOA. Some old hippie caught a high tripping on acid. My husband's favorite one was Oscar has a hairy old arm, or whatever other A-word body part you would like to replace that with. We had the same geometry teacher. I don't even know where he learned that from, because I never knew it, but he told me that. So those are all the trig ones that you've done so far, and hopefully you guys already have these memorized, so it is not an issue. But if you do not, you definitely need to have this memorized. So make sure that you know that. Now, the other ones that I don't think you have seen that we're going to talk about today are, I'm going to actually put secant right here. Right out. Secant. You guys heard secant before? Connor has, but he takes weird classes, so I don't know. A couple of you have seen it. So secant is just the reciprocal of cosine. It is hypotenuse over adjacent. We also have cosecant, which is hypotenuse over opposite. Yeah, that's right. And then we have cotangent, which is adjacent over opposite. And cosecant and cotangent. So those are new. These are called our reciprocal trig functions because they're just flipped from the trig functions. If you haven't seen these before, the reason you haven't seen them before is because in application sort of problems, they're really not very useful, right? Because it's not easier to use cosecant than sine because it's just using the same parts, right? So we just use sine, cosine, and tangent. And we can pretty much do everything we need to do with sine, cosine, and tangent when it comes to solving actual, real right triangles. So that's why you probably may not have seen these or maybe are somewhat unfamiliar because you haven't used them much. To help you remember these, I always teach students for the reciprocal identities that you must have a co with every pair of identities. So obviously tangent and cotangent are going to go together. So you got opposite over adjacent for tangent. Cotangent is just the reciprocal of that. Now, it seems like sine and cosine should go together, and cosecant and secant should go together, but they do not. So sine is going to have to go with cosecant so that there is a co in that pair. Sine cannot go with secant because there would be no cos in that pair. So, so sine and cosecant are reciprocals of each other. They're flipped. And cosine and secant go together. You got cosine and secant, which has a co there, so that they are reciprocals of each other. So you will need to know these. We're only going to use them for just a little bit of stuff in this first unit, in Unit 5. They are going to show back up again in Unit 6, where we'll see them even more. They're, like I said, they're not, Unit 5 is mostly just like real-world application stuff of triangles, and these don't show up nearly as much there. They're more theoretical sort of things. You will see them more in Unit 6. But what we're going to see today is we're going to see things like this example here. If cosine of theta equals 3 over 4, find secant of theta. So this should be really simple here, because I know cosine is 3 over 4. That means my adjacent side here would be 3. My hypotenuse would be 4, or at least in that ratio. So if I want to know secant, all I've got to do is just flip that, because those are reciprocals of each other. So I would get 4 over 3 for that. And so those are the most simple, is when they are actually the reciprocal identities of each other. Another type of problem that you're going to get is something like this. If sine of theta equals 3 over 5, find cotangent of theta. So this time I've got opposite side over my hypotenuse is 3 over 5. But cotangent is adjacent over opposite. Do we have our adjacent side? We do not. But we can find it because we know that we're dealing with a right triangle here. So if I draw a right triangle, we'll label that theta right there. My opposite side would be a 3. My hypotenuse would be a 5. How could I find that missing side right there? Pythagorean Theorem. And this one should be one that you know, because 3 squared plus 4 squared is going to give you 5 squared, but you could solve it out if you need to. So you should get 4. But that should be one you're familiar with. So if you have, for Pythagorean Theorem, 3, 4, 5 is your most basic Pythagorean triple, meaning that it's going to give you, it's going to work for a right triangle, and they're all whole numbers. So, so that adjacent side there, this is my opposite. This is my hypotenuse. This is my adjacent side. That adjacent side would be 4, so we would get 4 over the opposite side, which is 3. So that would be our answer for this. You're not finding the length. You're not finding the angle here. You're just finding what that cotangent ratio would be. Let's do one where you end up with roots in the problem. So let's do number 3 on the worksheet there together. So for 3, if tangent of theta equals 7, we are supposed to find cosine of theta. So we're going from tangent to cosine. Those are not reciprocals of each other, so we're going to have to draw a triangle for this one. So I'm going to draw myself a triangle. Label that theta. Here's my right angle. Now, tangent is opposite over adjacent, but I don't have a fraction here. I just have 7. So what am I going to do with that? How can I make that a fraction? Put it over 1. So I'm going to put this over 1, and so this is my opposite. This is my adjacent. So opposite side would be over here. It would be 7. Right here I'd get 1, not drawn to scale, of course, here. So to find that missing side, I need to do Pythagorean Theorem. So I do 1 squared plus 7 squared equals c squared. So that's going to be 1 plus 49 equals c squared. 50 equals c squared. And I will square root both sides. I want exact answers on these, not decimal answers, so we need to break that down. That'll break down into 25 times 2, so that would be 5 square root of 2 for our C. So that's telling me this side right here is 5 square root of 2. Now for our cosine, Jackson, what sides do I have for my cosine? What's the ratio for cosine?
Adjacent over hypotenuse.
Good. And in my triangle here, Jackson, which one is my adjacent side? 1. And hypotenuse?
5 and 2.
Right, 5 root 2. So we will have our cosine of theta would equal 1 over 5 square root of 2. But I don't like to have that square root in the denominator. This is what we did on that last unit. We need to rationalize the square root. So, Bronwyn, what do we do to rationalize that square root? How do we get that square root out of the bottom? Good. What are we going to multiply by? All right, what do we multiply the top and the bottom by? Okay, you can use 5 square root of 2, but you only have to use the root, and it'll be much easier to break down. You won't have to have it to simplify as much if you only use the root part. So let's just do the root 2, and so we will get square root of 2 over 5 times 2, and that will be square root of 2 over 10. And so that would be our answer for this problem. Okay, questions? All right, so I'm going to give you a few minutes to work on this worksheet before we go over some of the, a couple of the other things for regular trig. This is more theoretical. They put a lot of this stuff on the ACT sometimes. This is understanding the ratios and how they work together, but you're not really like solving a problem. This wouldn't be necessarily useful if you have a triangle you need to know the side of. But it does help making sure you understand how the ratios of the sides work together. But we're going to work on this for a minute, and then we're going to do some that are just like straight application problems. We know cosecant of theta equals 6, which I'm going to write as 6 over 1. And they're asking us about tangent here. So if we draw our triangle, Cosecant is the reciprocal of sine, so it is hypotenuse over opposite. So we'll put that 1 there for the opposite side, even though it's not there. So that means on this triangle here, hypotenuse will be 6. Opposite side over here will be 1. And so we are looking for this missing side right here, which I'm going to call b. So 1 squared plus b squared will equal 6 squared. 1 plus b squared equals 36. So b squared equals 35. And we will square root both sides of that. So we're going to get here for this bottom side, we'll get square root of 35. And then our tangent is opposite over adjacent. So that is going to be 1 over the square root of 35. And to rationalize there, we got to multiply by square root of 35 on the top and bottom. So we'll get square root of 35 over 35 for that one. Okay, which other ones do we need to look at? Okay, so let's talk about solving triangles. Just really quickly, this should hopefully be a quick review. So just to remind you, first of all, when you're using, it doesn't matter if you're using our calculators or Desmos, default on those is radians. However, everything I'm giving you right now is going to be in degrees. You probably don't know much about radians, if anything about radians right now. You might have done a little bit with Coach Wood with unit circle, like pi over 3, 2 pi over 3, that sort of stuff. But for unit 5, we will be all using degrees completely. Unit 6, we will start into some unit circle stuff. So, let's see here. I was going to pull up Desmos. So, the first thing you need to make sure that you do whenever you're doing these problems, this was classroom, wrong thing. Alright, is if you're using Desmos, go over here, click the wrench, go down here where it says radians and degrees, you're going to click degrees. The default is radians. If you're using radians, you'll get your answers wrong. Or if you're using the calculator, and you need to know how to do both because there's some of this stuff I may just give you the calculator on. So if you're using the calculator, if you hit mode, down here on that third line, you're going to go over to degree and hit enter so that you're in degree mode there. If you don't do that, all your answers that you'll get will end up being wrong. So let's just briefly remind ourselves what to do if we have something like, I know this angle right here is 35 degrees, and this side right here is 4, and I want to know this side right here. Okay, so sometimes for applications I will just give you a triangle. Sometimes you'll have to read a situation and draw a triangle based on the situation. But if I want to set this up, I need to look at my sides that I have. Right here, I know the adjacent side, and this side over here is my opposite side. So if I've got opposite and adjacent, which trig function should I use? Which ratio is going to work? That's tangent. So we will say tangent of our angle, which is 35 degrees, equals opposite side over adjacent side. So we have tangent of 35 equals x over 4. we're looking for x, so this is really simple to solve. We just need to multiply both sides by 4 to get rid of that 4, and we will type 4 tangent 35 into the calculator, and we'll get 2.801. Unless I tell you otherwise, keep 3 decimal places on your answers for me, so that opposite side would be 2.801. Alright, so if we had a triangle like this one, let's see, we know this angle right here is 27. Grace, 4, is that going to be opposite, adjacent, or hypotenuse? Opposite. And what about our x right here? Hypotenuse. So for opposite and hypotenuse, which one should we use? Sine. So we're going to have sine of our angle is going to be the opposite side, which is 4, over hypotenuse, which is x. Now, this one's a little bit tougher to solve because the x is in the denominator. Not too bad. And we're going to do lots of these, so you'll probably remember pretty quickly how to do this without having to show every step. But we can't solve for x's while they're in the denominator, so we're going to multiply both sides by x. So we've got x times sine of 27 equals 4. What we have to remember here is sine of 27 is just a number. Right? If you type it into your calculator, sine of 27 is this number right here. Right? So sine of 27 is just a number. So you could change it to a decimal here. I'm just going to divide both sides by sine 27. So if we do 4 divided by sine 27, we are going to get 8.811. You'll notice what happened there is that the sine 27 and the x basically just like switched places. That's going to happen every time whenever you have that x in the denominator here. Some of you may shortcut that. Okay, these are both for finding sides that you are missing. You also need to be able to find angles that are missing. So let's say that this side right here is 6 and this side right here is 7, and that we want to know this angle right here. So whenever we look at this, Reese, 6, would that be opposite, adjacent, or hypotenuse? It is opposite because our angle right here is over here on the side. And then 7, what would we have? Is that opposite, adjacent, or hypotenuse? Adjacent. Good. So if I've got opposite and adjacent, which trig function do I need to use? Tangent. So we will write tangent of theta equals 6 over 7. Okay? I need to solve for the theta. I need to find that angle, which means I got to get rid of tangent. How do I get rid of tangent? So like, that means I'd have to do in my calculator, I'd have 6 over 7 divided by tangent. It is not like It's not cotangent. How do you undo a tangent? Not times it by itself. Look at your calculator, particularly around the tangent area. Inverse tangent is what we have to use there. So we would do inverse tangent, which just cancels out the tangent. And then over here we have to do inverse tangent as well. So that on your calculator, if you're using the handheld calculator, you're going to hit second tangent, and it's going to have that tangent to the -1. That's our inverse notation. And then we would just type in 6 divided by 7. And so we'd get 40.601. So theta would be 40.601 degrees. So you may want to make yourself a note here. To find an angle, you must use inverse trig. And just to show you really quickly, also, on Desmos, if you're wanting to do inverse trig, I believe it works if you just type in tangent to the -1. No, that might not. Of 6 over 7, yeah. So you can type in tangent to the -1 power, 6 over 7, it works. Or inverse tangent is going to be here on functions whenever you see it. So basically with these problems, you're either finding a side or an angle, right? So I have a worksheet that we're going to do, and I think I'd like for us to work together on these. And I'm going to let Delta Math pick our groups today. Let's see, so we've got everybody. Let's do a group of 3. Alright, so first group is going to be Braden, Jackson, and Reese. So Braden, Jackson, and Reese. Next group, Noel, Summer, and Connor. Alright, next group, Blaine, Hallie, not Noel, he's already been picked, not Jackson, and Bronwyn. And then that leaves Maddox, Grace, and Caitlin together there. So go ahead and move to your groups. I'll bring you your worksheet that you're going to do for me. Whenever you get to number 5, sometimes students get tripped up on that because their geometry vocabulary is not great. Equilateral triangle has all sides the same, and this line right here that is perpendicular